All right, so this stuff, what do you make of this, Nick?
Well, is this too coarse for Lewis?
Of course, for lists, but not for sand dunes, right?
Sand dunes?
Yeah. So maybe that's what we're dealing with, and in that case, maybe this pond is just blocked off by dune sand. That's probably the simplest explanation for it.
Now, big picture wise, you're taking us to some very delicate beds tied to the Ice Age floods. Is it an accident they're right here? Are we in this protected side of Steamboat Rock?
I don't understand how that works, but yeah, we're in the lee of Steamboat Rock for floods that would be coming down from the Coulee intake. Yeah, you can, because the Coulee intake would be, up there.
Sure.
And yeah, so they're strung out on this side, and then from the prow, is that the right term?
I think so.
Of Steamboat is ridges. This has, here and there are cobbles and pieces of boulders that stick up through here, like this guy. So it's likely that there's a cobbly or bouldery flood bar trailing off of this side of Steamboat, and the dune sands come in recently, and there's another
dune sand far younger than the ice.
Yeah.
And so the beds we're heading to maybe once upon a time carpeted the entire floor of the upper Grand Coulee, and now there's just a couple little pieces left.
Yeah, so.
And you're not finding these all over the place. There's just a couple places for you to look at some beds.
We'll see two kinds of beds, and there are lots of puzzles with these beds. My prior experience here in 1985 was a single day.
A single day?
Yeah, out here.
Oh.
Okay? And I logged a section and I published it, but in a way it's an example of how for a feature this grand and classic, as far as I know, nobody's tried to work the stratigraphy of those deltas.
Wow.
But I guess the idea with them is that they are deltas built into the river lake that was in here. And why are they above present Banks Lake level? If Banks Lake has a dam down, it's actually higher than Dry Falls, right?
Right.
So what could do that for you? All right, think of it this way. Waterville Plateau was glaciated, right?
Yes. Oh, good. Yes.
Okay. And the site of Grand Coulee Dam was overridden to the other side of Steamboat, and there's some thought that there's glacial drift on top of Steamboat.
Sure.
And then Bruce Bornstad a few years ago in a kayak came upon striae. I think there's a photograph in your little packet of those striae. Richard published it recently in a paper.
Okay.
Our destination is that point over there.
Nice. So how thick was the ice here generally? How can you estimate the thickness of the ice?
I don't know, but let's say if you go east of the town of East, is that right?
I think so, yeah. Because up on that bench, aren't you extrapolating that the ice margin was sitting up on top of that?
If you go east and south, I think of the town of Grand Coulee, there are glacial features. There are great big haystack fields going up Columbia River Valley from there, and so at least the intake to Upper Grand Coulee was overridden, as was the dam itself. Mm-hmm. The dam work. Are you familiar with the dam geology?
A little bit.
A little bit. Have you seen the paper by Flint on that? It's really wonderful.
Is it?
Yeah.
The arch enemy of Brett's is
Oh,
doing
yeah.
some good work.
So he figured out, he was the first to describe the style of stratigraphy you see where a stably dammed lake, ice-dammed lake,
Yeah.
lay in the path of periodic floods from Lake Missoula. He encountered that kind of stratigraphy underneath till in boreholes and exposures at Grand Coulee Dam, and it was really the dam geologist, I think, named Irwin, an engineering geologist, who did most of that work. But so the paper is Flint and Irwin.
Back in the 30s?
In the 30s, it's published in GSA Bulletin in 1939, and they have a fold-out cross section with lots of detail showing where their borings are, and then they have a little blow-up showing three-part sequence, and they have I can't remember, sand and thick silt and varves or something like that, and it was a repetitive sequence, and it's just the stuff that you see. So and they said, well, how can you do this? Well, there must have been some lake upstream that was periodically sending floods down.
Right.
So I mean, they had the whole story.
They had it.
But it was way too gradualist for, you know, Brett's allowed for multiple glaciations to be involved in the multiple glaciations worth of floods to accomplish this. But he kind of, early on, he was one flood does it, right? And so for it would have been a stretch, I think, for Richard Foster Flint to relate what he was seeing there to the cutting of Grand Coulee, because they didn't have 40 floods down near Walla Walla. Right. And so that mindset wasn't that idea wasn't there. I don't know if they had if they knew about the modern examples from Iceland and elsewhere of lakes that rise high against an ice dam and float it, and then.
Interesting. So when I first saw you this morning, you said something that really surprised me. When you were up in northern Washington here doing some initial geology work, it was not Pleistocene. You were doing bedrock geology, and did you say you were doing this sand poil, glacial Lake Columbia stuff just for fun on the weekends?
Well, it worked kind of like that, because my main responsibility was to map quadrangles. Yeah, I had, and the senior people in charge, they were generous to a fault. They thought, okay, we've got these young people. There was me with the survey, and then there were some grad students from Washington State University, from University of Idaho, from Missoula, really talented people with interests and background in igneous rocks mainly.
Okay.
And a lot of the geology we were wrestling with was with intrusive igneous rocks.
This is the very early 80s. You're fresh out of PhD stuff on the East Coast. This is your first time in Washington, kind of?
Yeah, that's true.
Less?
That's true. Yeah, okay. I was living in San Francisco, and we would commute summers. We got to spend, one summer we spent close to 5 months up here, I think.
Okay.
And we had trailers that provided a place to ink your maps in the evening. Wow. And there's nothing digital here. Of course, we were working with paper topo sheets, and the base maps available to us were mile to the inch, 15-minute sheets. With in the case of the Sampoil, the country was steep enough that the contour interval is 80 feet. And you went around with an altimeter, and whenever you were going up a ridge and you hit a point that looked well controlled on the topo map, you'd check to see how your altimeter was doing, and in that way, together with other cues in the countryside, right, you'd figure out where you are.
Yeah.
And it was no messing with pointing with GPS, and a great advantage to that, of course, right, because to locate yourself on the landscape means really locating yourself on the landscape, not just on the ellipsoid. I think the person in charge who assigned me to this, it's the one and only assignment that I ever received in the U.S. Geological Survey. Everything else, I was just given an infinite rope, you know? Well, and whatever interested me, pretty much I could do.
I think you earned that freedom. They probably saw your skill right away. Don't you think? All modesty aside?
No, I think it was the culture.
Huh.
And a management style that was applied to a lot of people.
I see.
That and maybe to some extent for some of the individuals involved, that, you know, managing people's difficult. It's a lot easier just to let them let them sink or swim on their own. Yeah, so I felt I increasingly in my work in my mapping work up here, I let myself get diverted, and I started working with the lake deposits, I guess, in '81, and I think it was in '82. I stayed really late into the end of October, and I was reviewing some field notes about logging a section in the Sampoil Valley on a morning when the thermometer at the trailer read 17 Fahrenheit, and that my hands were barely, you know, couldn't.
Yeah.
But my field notes in those days, well, I can barely read them now because the writing was small.
Sure.
And I've developed a bit of my mother's palsy.
Okay. So
my field notes these days, I can barely sketch. You know, I mean, there are things that it's a little sobering to be 69 years old and realize there are certain things you could physically that you can no longer do in as basic as and important as sketching stratigraphy accurately.
So why are you back talking about Ice Age floods? It's been more than 35 years that you've been looking at and thinking about this stuff. What has gotten you back to this?
Geological Society of America field trip.
But there have been plenty of other GSA field trips to Ice Age floods. What's special about this one? Somebody asked you to do this?
Yeah, so Richard Waite, who worked out the evidence that initially that except of course Flint beat him to it, but Flint Flint didn't really. Richard. Anyways,
yeah.
So Richard thought it was time to, and maybe Jim O'Connor also felt that it was time to cast fresh eyes on Grand Coulee and its origins.
Wonderful, wonderful.
And Richard recognized that, oh, it's getting harassed. Oh, look at the...
Wow.
So Richard recognized that the Sampoil Valley, where I'd gotten to work in the early 80s, being just upstream, is a place to monitor the flood flows that came down through here, and that the records of flood flows there, because it's a back flooded setting, there's a better chance of preserving everything. So we felt it was important for the trip to spend a day in the Sampoil. So he's and the tribes have been gracious, and the Confederated Tribes of the Calva Reservation have been gracious in granting a permit that's allowed me to come up and do a reconnaissance to find out what's what's left of exposures that were there in the early 1980s. Some of them are gone.
Are they?
And yeah, grown over.
Huh.
But anyways, and then also the progress, like with the Michelle Hansen and her co-workers in the early 2000s, coming in there and finding this Mount St. Helens ash that helps to knit the Missoula flood history inferred from the deposits of glacial Lake Columbia,
Yeah.
to knit that with stuff down on the in southern Washington.
So that wasn't in existence when you were doing your work in the 80s.
No, but the tephra was in southern Washington. It was just that I didn't have the wit to recognize that was an ash. Oh, so what do we have here? There's some architecture in this one too.
Okay.
Is this going to be too much of a drop? Let's see.
Whatever you want to do, I'll do.
No, we both have old knees.
That's true.
Let's go here.
Okay.
We'll need those knees to get back. So what do you make of this? So there are rhythmites and there are rhythmites.
Okay, I'm listening.
There are flood rhythmites and there are glacial lake rhythmites. And
not varves.
these are probably our river lake varves.
Well, if you wouldn't mind, like, how do you use varves versus rhythmites versus graded beds? I mean, I think I hear people using them interchangeably, but they're not really, are they?
Okay, so varve is a genetic term, right?
Okay.
Because people speak of varve years, so if you say that the stuff is varved, then you're implying that the rhythmic repetition is annual.
Correct.
Right? And so here, how do you demonstrate that the pattern of sand goes up to clay, and then sand goes up to clay, and sand goes up to clay like that, and it just repeats. It's okay. They're not perfectly rhythmic in that this and this are much thicker than this and this.
Right.
But nature varies, and so you allow for that. So if you treat these as years, what do we have? This would be considered the winter time when the flows diminish, and then when the melting occurs in the ice sheet, then you increase the current and you bring down this coarse silt and some very fine sand.
What tells you the darker stuff is summer versus the lighter stuff being winter?
It's grain size, isn't it? And especially here, you can see the horizontal layering. Mm-hmm. And then there's a little ripped up piece of winter.
Oh, wow.
Yeah. That's very pretty.
That's sweet.
There's some erosion nick that takes place in here, and I don't quite figure it out. Because, okay, like before you can lay in the smile of light colored stuff over there, you've got to somehow truncate the beds that end against it, right? And likewise, this material is just at the lowest part of a section that has probably about 12 flood rhythmites that go to the top of the bluff. And then this material here is trying to climb over the top of it, but it can't. And
wow.
And then there's the further complication. We saw how brown this was.
Right.
And if these really are varves, they're I don't know what it is, but there's something that makes them brown, probably some oxygen. But the varves that are associated with these are greenish and gray, and they're thinner.
Huh.
And does that have something to do with your with the story of ice having been here and weighed down the landscape?
Oh.
And so early on, your lake is deeper. And then if there's an isostatic rebound, you shoal the lake.
Yes.
Okay? And in the meantime, while you're doing that, you have, in interflood time, you still got the Columbia coming through here, and it's moving all over the place. And so it's cutting into stuff here and there. So you have an opportunity with a river or a river overflow to make channels that truncate stratigraphy. I don't get it here,
right.
But in 1985, I wasn't thinking along those lines. But coming back here, these questions, and prompted largely by others, like the archaeologists,
yes.
in the past few days, now what's this and why and how did you get it this way? So there are a lot of really wonderful things to be teased out here, and you can imagine that there are other clues on other shores of Banks Lake.
Of course, yes.
You know, even I mean, okay, down there, those look light colored and sandy. Down there, those may be also of the style of what's around it. But let's see what's around the corner. You'll like this stuff. So what do you know about cementation of till?
Oh, good God.
I know nothing. But
thank God these are rhetorical questions. Oh, look at this.
Maybe it's not that cemented, but it's pretty. In Seattle, they say that the till is like concrete. So
yes. Wow. This isn't Wisconsin where you can pull boulders right out of the till. It's sandy, it's loose. I mean, this
is pretty tough stuff.
Yeah.
But okay, so if it is till, it is a diamix. It's a non-sorted mix.
yes.
Are any of the clasts in it rounded? I guess this one is. That one is. There's some angular ones too. Huh.
So the ice is here at this point. The earliest part of our story, the ice is in direct contact with this elevation.
And it's loading the mantle underneath us. And the surface here is sinking. And eventually that's got to be undone. And probably that also works into this story. Okay, but then you've got a gravel bar that's built on, evidently it's built on top of the till. The till doesn't extend onto the top of the gravel bar, right?
Right.
So if we peel this back, the very base of our section, ignoring the basalt and the granitic rocks, the very base of our section is probably this diamix that might be a till, and that might record the ice being in here. All right, so that gets to the nub of one of the partly to the nub of one of the coulee issues, which is when did the Niagara Falls kind of cataract that Brett's imagined, right? That if that's retreating steadily up the coulee and giving you the landscape you see, when did that intersect Columbia Valley?
The breach.
Yeah, and breach it, right? And so there's some evidence that it's difficult to explain deposits downstream with a coulee that's open, because the coulee provides too much of a safety valve, and for floods during the last glaciation to run down Moses Coulee. But in some of the computer simulations, it's difficult apparently to make that happen. So and there are, near Wenatchee also, there's a high bar, Pangorn, I think it's called.
Yes.
You know this one. I'm not familiar with it, but apparently it's hard to get, even in the simulations, in any of the simulations, it's hard to get the floodwater up over that bar to account for and it's especially hard if floods running down Columbia Valley have this as a safety valve, because it siphons off.
Yes.
Okay, so there are those reasons to think that the coulee wasn't complete. But on the other hand, at least the cataract retreat had gotten this far. If that diamect is a till, by the time the Okanagan lobe gets into Upper Grand Coulee, it's already cut.
It's got to be cut, right?
Yeah.
It wouldn't be down here otherwise.
Yeah. But that doesn't tell you about when you get completion.
Right.
Well, anyway, so we had a step one was a till. Step 0 is cutting the coulee to this depth.
Right.
Before the till gets laid down.
Gotcha.
Right, and then the till, then gravel bars laid in after the maximum of the Okanagan lobe. After the Okanagan lobe backs off onto Waterville Plateau over there.
But we're still blocking the Columbia.
Or you're still blocking the Columbia because the blockage can go all the way downstream to Bridgeport, and
okay, so post maximum ice. Okay.
So energetic floods after the maximum lay down gravel bar, and we're probably walking on a dune covered part of that gravel bar. Okay. And then,
oh baby,
and then some late floods come in and do this.
Oh my God. Woo! Oh God. How did I not know about this? Wow. Oh. And you were here for one day in 1980, whatever.
Yeah, summer of '85. Maybe I may have come out here too. I may have seen it in reconnaissance, and I think my mode would have been that there was grass would be always greener around the corner, and so I just better keep looking. I don't remember whether I did reconnaissance by canoe here or on foot. All right, there's some really basic stuff with this, this is an easy exposure in which to see it. All right, I don't know if we can get, here we have, I can't read the current indicators here. They would seem to be, if those are forsets on the front of a ripple, they would seem to be heading that way, right?
What the heck?
But there are all sorts of possibilities for eddies. And you're in the lee of Steamboat Rock, and you can imagine the flows being really complicated. But anyways, this brown cap is just the hallmark of the glacial of the
sticky that is.
And
Lord.
Then above it, now contrast. I don't know how many varve years you're looking at, but you could say 1, 2, 3 like that, something, right? Sometimes in the weathered exposure, you can get a sense of varve counting better.
Are you still thinking dark is summer and light is winter?
Let's see. It's all so fine grained compared with what we saw around the corner, right?
Oh.
And that's part of the evidence for a deeper lake here somehow. With an emotionally depressed landscape, right? You know, I mean, it's just, the ice has been here and it hasn't recovered.
So let me pause you for just a second because I'm thrilled, number one. Number two, there's nothing in here to give us an absolute age. We have no idea. There's nothing in this section to a tephra or something to help us.
Okay, there's numerical ages. Numerical ages are, in some ways, they're a headache, right? They're all sorts of, you want to get numerical ages out of deposits like this. You struggle in many ways with assumptions about this and that, and the sequence we were developing of the ice was here, then there were energetic floods that laid down the boulders. These aren't bouldery, so they're less energetic, right? And then sometime after that, you have just a river lake here that's laying down those thick varves, and that's really the framework of the story. And yeah, in the end, you may be able to put some numbers on where you are in calendar time. But if geology is storytelling, putting numbers on particular times it's important. But it's not the whole of the story.
Gotcha, Brian.
Right?
I gotcha. So I know it feels like I'm trying to steer you, but I'm not. I'm just trying to keep track of some of the basic storylines.
Right.
The ice is gone. We're on top of the till, of the diamict.
Yeah, and
So-
we're on top of cobbly and bouldery flood bars, but we still have flows energetic enough to interrupt the usual glacial lake conditions that are represented by these greenish varves. Now I don't know how to count. You know, how would you count time here, Nick? Would you say that's 1 year, that's the next, or would you group them together, right? And so, I don't know, the way I did it in the sample, I didn't have, and I should have done the reading. There are ways, I guess, there are criteria you can use to say, this clay stuff is a winter horizon, as opposed to this clay stuff rained out of the water column after a turbidity current, or some density current going down the bottom. And it's just part of an upward grading of that particular sort of flow event, right? And I didn't know, and I still don't know what to do about that kind of thing.
I mean, I ran.
But there aren't a lot of years in here, however you reckon it, right? You could say 1, 2, 3, 4, 5, 6. You probably wouldn't count that one, right?
There's nobody that argues against you here. Like
1,
this is not
2,
annual.
3, 4, 5, 6, 7, maybe.
sakes.
Or you could do a stingier count, right? You bundle this as 1, 2, maybe 3, 4. You know, maybe the minimum would be 5, somewhere between 5 and 10, rounding it.
Okay.
Right, so you asked about dating.
Yes, I did.
And this kind of dating that you can do in the field,
Right.
it's really important, and it's a way of positioning yourself in a Missoula flood sequence. And let me inflict this on you. It's not worth your batteries, maybe at this point.
Well, it might be. Are we going to something?
We'll do something. We'll do it. We could do it again after you figure, because it's going to take me a while to find this.
While you're looking, you're counting years. Glacial Lake Columbia has to be here during that time. You're in the lake floor with these varved sediments. Are you not?
Right. The problem is that the varves, see how deformed they are at the top, and here you come around, varves have been squirted up,
Okay.
And so you're not getting the complete sequence. That's the devilish part of this. And that gets in the way of a very nice piece of work from Canadian scientists who, over in the Sampoil Valley, recognized a volcanic ash layer that I logged as a silt layer in 1983.
Is that right?
Yeah, but I didn't know it was ash, and they're out there sampling it, and they say, we better take a look at that. And so that probably matches with St. Helens SG in particular, which is between about 15 and 16,000 calendar years old.
Okay.
And the cool thing about that is that SG and its mate SO, or the couplet that you see in the Walla Walla Valley, Yakima Valley, it's been found. Those have been found between the crests of giant gravel current ripples.
Yes.
There are flat-lying deposits that filled in the swale over near Spokane, and those tephras in there. So they're from later, relatively modest floods, right? Here we have time's arrows pointing that way, and time's arrows also pointing this way. But this is time through the last glaciation at different glacial lake sections. And there are rhythmites like these that have been counted, and the counts all down here are from bottom sediments of glacial Lake Missoula, and the uncertainties in the counting are reflected in part by the observer differences that Chambers counts at the 9 Mile Creek section that you have in one of the videos you sent me. It's in there, right? So Chambers did the original work, and Chambers was on the generous side, and Michelle Hansen was on the stingy side. But so you can see, so Brian was both generous and stingy. Okay.
Oh, this is third person Saturday. I like it. Brian.
Yeah,
Good.
but I'm just trying to put it in that.
I got you.
So when I did this work, I threw up my hands as I did here, and said, okay, I really don't know the exact number of varves that are in here, but I'm going to make a stingy count, a generous count. And then there were varved intervals that were eroded, so that on this graph they're gray. But in any case, time through the last glaciation is running along this x-axis.
Yep.
And then on the y-axis is time in varve years for what they're worth, right? And with almost
I got you.
air quotes around it
I got
because
you.
of the uncertainties in doing that.
Yeah.
Okay, so they found that tephra up in this part of the section, and it's after in the Sampoil, a plateau near about 20 varves per interflood interval, and it's a long plateau going through, I don't know, 30 or more flood cycles.
Yeah.
What I'd like to be able to do for dating of this would be to locate by varve counts
I see.
where you are in the section. Are you out here
I see.
after the set S, or are you back in here on this plateau? Or you're probably not here. These are probably, okay, and I think the Okanagan lobe's at its maximum by indirect evidence around here. So in terms of the history we've been looking at here, that then, and I don't have we could, with the varve counts and the set S age, we could go ahead and apply ages to this, but they would complicate the diagram. But the floods here were destructive enough of the varves that you can't count them. That's one thing. And then the second thing, you'd love to find that tephra here.
You sure would.
Okay, but you know where the tephra is in that section? It's in a varved interval that's yay thick.
Up in the Sampoil now.
Yeah.
Yeah.
It's at the tippy top. At the tippy top. And you're in this backflooded side of Sampoil Valley, so it's doubly backflooded. First, the Missoula flood has to come down Columbia Valley, and it has to take a right angle bend into Sampoil Valley, and then it has to do another right angle bend. Okay, and And so what you end up with is this very passive setting, and the Missoula flood, the stuff just rains out of suspension and covers this, and there's not a trace of evidence for erosion into the, but it's right there at the tippy top of a varved interval that may have 10 or 12 varves, something like that. So you'd love to be able to match it to this, but I think they all get, you'd have to find the top of a varved interval preserved, and you immediately see the problem with the way that the floods are making a mess of things. For flooding of places like Pangorn Bar, right? Imagine what you do to your flow if you entrain a lot of sand and silt from this. Yeah. You bulk it up and you increase the volume of the flow. And the simulations that have been done thus far assume the flows are watery.
Oh, I see. Yeah.
And so the initial thought was, the Missoula floods did a good job of entraining loess. So we're going to allow them to entrain a lot of loess. But the glacial lakes in the path, Glacial Lake Columbia upstream of Grand Coulee Dam, but also the river lake here, and probably another river lake below Dry Falls.
Oh yeah.
Right? And so there are all these opportunities to pick up sand and silt and clay. And so they make for that may help in the end to how do you want to say it? The simulations need to reach high water marks that they don't yet reach, and with all the volume that they get by having an instantaneous dam break at Lake Missoula, right? And throwing all the water of a maximum Lake Missoula down. Apparently they can't get it. But for that, you need, really, I shouldn't be talking about that. It's Jim O'Connor and others who are doing, Roger Denlinger.
God, what a thrill. What a thrill to be here.
Now, where can we see this well? Okay, you'll really like this. All right, what do you see here?
Varves and sand below.
Yeah.
Oh, and then something above.
Yeah, a diamict.
Wait, is this sloughing off?
That's sloughing off, but I think everything else you're seeing there is real. Let's see if it continues down here. I think it ends somewhere down here. The diamict is still here. Now we're not thinking and the diamict ends somewhere in about, everything gets cut out here. Here's your brown top. It's getting sliced out. There's all sorts of geometrical wonders here. Yeah, and and then drop stones, right?
Out of what? Icebergs?
Yeah. Or like here, there are plenty of them back here. They're more convincing over here.
I'm trying to keep up with the master here, but I hope you're catching that our varves mean we have a lake, Glacial Lake Columbia, and now Brian says we got drop stones
and
in the varve stuff, and the diamict, which I don't get.
I don't get either.
With granitic stuff in it. You didn't have this in sandpoil, did you?
Yeah,
you did?
In some ways. There were layers of diamict. The one radiocarbonate I got out of sandpoil was wood out of diamict. But this, all right, so what about this one? I haven't tried to dig this guy out. Let's see if we can figure out, was this drop stone, does this belong with the varved?
Oh my God,
stuff around it.
What the hell?
Let's see if we can. The problem, okay, this is a hard outcrop to work because you want to clean here, and when you do, it just it just keeps coming.
They're just hanging there.
But let's try anyways. Oh, that's in. That's the diamect. Okay, so this phenomenon is pretty common of having varves, silt, and clay squirted up into the sand that's loading it.
That's common, really?
Yeah, in the Missoula flood deposits of Glacial Lake Columbia, that's a really common thing. This is a good view of it. It's almost like a little T, isn't it? That's a common shape of it.
It's like a little dike?
Yeah, it comes up like an intrusion almost, but okay, and then we hit this stupid diamond. What's it doing here? And I'm dulling, I sharpen my, so I can cut things nicely, and here I am dulling on. Okay, I just lost, but we still have that one.
God, this is amazing. Thank you for inviting me to be here. My God, look at that.
Well, it's too complicated.
I mean, our viewers are just going to be blown away by so much, including such variation in this little slope along Banks Lake that most people wouldn't give a second thought about.
Okay, so did this look at how this is squished downward. So did this, I don't know how drop stones work. Oh, look, this is connected to the diamect. Oh. Okay, so let's assume that this is a conformable contact, and that you've got a couple of years after the flood represented by this, and then something floats in here. But how big of a berg would you have to get a tabular layer? Suppose this is being carried.
What do you think of this whole thing as the drop feature?
I don't know how else you get it here, and the drop stones are just part of the. This looks like the drop stone is, well, look, there's a little bit of varve separating the top of the drop stone from. Yeah.
Okay, so there goes that idea.
So this drop stone. The drop stone's an early warning system. It says there's garbage headed your way.
That drop stone appears to be encased in the varve. It's got varve on all sides of it.
Yeah, but at the same time, the drop stone appears to have loaded the varves. If I can
loaded. What do you mean? Oh, they depress them down.
I think so. Do they get thinner underneath it?
A little bit, maybe.
Yeah. Curiosities. Yeah, this is.
Wow.
There. It's not a lodgement till. All right. So what's another possibility?
The diamect you're thinking about. What else?
Was it injected during the succeeding flood? Because look, it's this varved stuff and this varved stuff are probably part of the same varved interval, but this part of the varved interval is nearly everywhere we see it. Oh, like, here's one of these flames coming off. You see it? This rising up here.
Oh.
It's difficult. It's difficult because we're dealing also with this talus. We want a vertical cut through the sand here, and if we undercut this, we'll just bring it all down. And I don't know. We should leave this one for maybe here we can get an idea.
So when you were here in 1985, did you clean off a face from top to bottom, do you recall?
Richard Wade assures me that I missed this unit, and that it was covered and the lake hadn't undercut it. And so I started probably with that unit there. So it was good. I don't remember seeing the dimix. This dimix is present only maybe 10 or 15 meters of the face, so it would be easy to have overlooked it. Boy, these are dependably T-shaped. Yeah? Comes on up. There, you got a branch there, and then one tailing off there.
I don't understand this.
So the load of the sand is, don't you think that these are load features? You pile this sand up instantaneously on mud that's not very coherent, and it just squirts.
I mean, we're in classic dike country now in that whole discussion, right?
Yeah.
Look at that.
Oh, this is good. Look, we've gotten off the tail end, have we, of the dimix. So does that help us evaluate the dimix? This contact here is a wonderful reference, isn't it?
It sure is.
You know where you are.
My God, yes.
Oh, there's gypsum.
At some point, I think you're making this stuff up now. What the hell? Seriously?
Sure. See if you can scratch it.
Oh my God.
Your fingernails. No, so that's late game, right? I mean, this is from precipitating from the groundwaters. So how do you like that? That's probably bedding in the sand. It's truncated against that, probably because the mud got mobilized against it. So this got intruded into.
We're mobilizing because we're loading. Is that
loading, and God knows what this is doing to everything, and how it's getting in there. We're always sort of condemned to looking at the vertical face that we have,
of course,
and not imagining what's coming at us sideways.
Yeah.
Well, anyways, that's we could spend all day on that.
We could.
Let's see some more stuff down here. So what's that?
Dropstone.
Yeah. And that's high up in, is this?
We're out of our sand.
Oh dear. So now where are we? We have varves. We have varves here that are not resting on brown clay. So what happened?
Where's the brown clay?
Yeah, the brown clay should be under them. So this happens a lot with the varves from Missoula flood effects in Lake Columbia is that the varved intervals get dismembered, and slabs of varves get rafted up into the sand. It's just
way more energy than you would expect. You know, I just imagine this quiet bathwater. You got rip-ups of the varves incorporated up into something above it. You've got sand.
In a way though, what's amazing is, okay, so this is this same unit. It's turning brown in the weathering, but it's not that brown layer. It's the greenish varves. And it's sailing along here, Nick, for, oh, look, here, do we have something? This is helpful. Ah! Oh. But it was one of these injections, right? So there's a piece. There are pieces of varves.
Oh, I see.
Floating away. Ah, here, Nick, this one. That's a beauty.
Another T?
This one's no, it's an L, upside down L. And here's another. And they're all flopped over. And I don't know if they go with the current. Those are really cool. Boom, you know, if you have two things that are the same, they make a pattern, right? Okay, Nick, this is a better place to see evidence for injection. It goes wild up at the top there, but this one is almost doable. You've got the color change here.
Oh yeah, look at that.
And then the varves are squirted up, and then here's that sort of T-shaped form. And here it gets very messy.
So come on, these clastic dikes have to be Missoula flood related. They can't be
all right,
seismic or something else.
Those are the varved. This is why the Sed S tephra is not likely preserved here, because it's from the top of a varved interval, right?
Got it.
I mean, you're just
right. Well, there's just way more energy here than I expected.
But it's not, all right, this is low. I think a sedimentologist, I'm not one, would attribute this just to loading. You pile up the sand on top of soft mud and it squirts up. And it doesn't, the energy involved doesn't have to do with so much with whatever it takes to emplace the sand. Okay, that's, you know, there's some energy there, but it's not like you're dealing with great big gravelly flows here.
I see. Yeah.
So these could be, these are probably from their juxtaposition with gravel in here, and they're being post-glacial maximum, that they're just late Missoula floods from, you know, floods 10 or 20 years apart, something like that.
But you don't mean water from Montana. You say Lake Missoula floods because you're talking about the Missoula flood story, but aren't we just talking about the Missoula floods are done by now? Isn't that a big point from one of your papers long ago? That we don't have Montana water dumping into this to affect this stratigraphy. If we're very late, this is just local glacial Columbia stuff?
Okay, so there is, I think there's a view that with the Okanagan lobe pulling back on Waterville Plateau over there, that the Okanagan lobe would somehow let loose from underneath itself periodic floods that would come into upper Grand Coulee and give you this alternation between varves and not varved. But the simpler explanation, based on what you see at Lake Roosevelt upstream from and around the corner at the Sandpoil, is that these are the sandy units here represent late floods from Lake Missoula. And then the bottom, and then the varves we see from the river lake that was here throughout but where you have only those varves and no sandy interruptions, those are the post-flood units. we'll
God, I'm
we'll
still
see
fuzzy
them well.
on that. Still fuzzy on that. The breaching, the opening of the upper Grand Coulee.
Yeah.
The ice is here. The ice is not here. We're done with water from Montana.
Yeah. There's a whole sequence, and it's kind of, and then there's plenty of room for debate with those various steps. But probably the simplest explanation is that the coulee was already cut before the last glaciation even started. The coulee served as the low-level outlet for Glacial Lake Columbia, except when the coulee was blocked by ice maybe when it was laying down that till. Okay, and there would have been floods that ran through here before then, and we don't see traces of them, but you do see traces of them in the Columbia Valley. And then
you didn't just say the simplest is to view this coulee pre 20,000 years ago.
Yeah, that's
really?
Well, you should get Richard out with you he has evidence for lots of back flooding into Quincy Basin, with the gravels being very well weathered.
I'm familiar with that, but I thought we didn't have the Grand Coulee at that time, that this is water coming down the Columbia and then back flooding into...
Right.
But you're thinking this is all cut. How many people are saying that? The upper Grand Coulee's been cut pre 20,000 years ago.
This is one of the things that Bretz and Flint agreed upon.
Well, you're blowing my mind right now. Hang on.
There's a catastrophism in Bretz.
Yes.
That I think inclines us to want to have the upper coulee completed as in a very small number, in a not gradualistic way.
Yes.
But there were prior glaciations, and Moses Coulee, for instance, is very hard to explain as a last glacial feature. It gets used. It gets overwritten, a palimpsest, but and so when did Richard's question in a paper that's just now available in a GSA special paper, that he views Grand Coulee as a pirate, as a capturing drainage that used to so long as the Okanagan lobe was in the right position to allow flood flows to get into Moses Coulee, they did, because this wasn't here as a safety valve. And Richard makes an argument in there, independent of the glacial lake evidence here, that happened before the last glaciation. The evidence in Columbia Valley is largely negative evidence, that there are high strand lines in Columbia Valley upstream from Grand Coulee Dam outside of the ice margin, but they're quite slight. And had there been a long-lived lake up near the level of the plateau rim, especially on the north side of the river, where you don't have basalt with its own layers as a complicating factor, giving you horizontal things in the hillside. The horizontal lines in the hillside are quite slight on the north side of the river. It's hard to make them into those of a long-lived lake. So that was Flint's initial view of it. He laid this out in 1935.
No kidding.
And he in some ways was following Bretz in that, because for Bretz there was the complication of where he fits his flood into his so-called Spokane glaciation. Correct, and he had his ice margin in funny places.
Yes.
Right. But but Nick, we can't. This isn't we can't here in Grand Coulee. I don't know of evidence we can use right here in Grand Coulee other than till like that at least says that by the time the Okanagan lobe reached its maximum, the coulee was already cut here, right? And the striae that Bruce Bornstead found farther north. So those are the within coulee clues, but the grand monitor of the intake to the level of the intake to Upper Grand Coulee in many ways is the lake behind it. And so you can inquire of the hillsides and of the deposits up there. No sign of Missoula flood to here, but down here we're starting to get into something suspicious that we've seen before, right? Ooh, this is very nice, and look at the way they interfinger. Now, were they deposited that way or were they injected as sills?
Oh, right on your diamictite too. I mean, this is.
Oh, we got our dimect here.
Oh my God, this whole thing, isn't it? Huge big wedge.
Yeah, good for you.
I mean, it's actually in stratigraphic position. Glacial till. Hints of Missoula flooding through here, but most of this varved glacial Lake Columbia sediments. But the trick is knowing where we are in time. Learning from the master.
Yeah, this is a nice exposure on that one, huh?
I guess so.
Because we haven't gotten to see the diamect in a vertical cut.